Okay, let's get started. So today I'd like to do SIMD conversion of RGB to HSV, so the opposite. So yesterday we did HSV to RGB. Today we're going to do RGB to HSV. Now RGB to HSV is like a little bit more complicated and not so easily parallelizable, so it's kind of up in the air about whether this is going to be faster or not. But you know, I was kind of thinking of not doing this. But usually when I'm thinking of not doing something because it seems hard, it's a good idea to just do it and see if you can do it and learn if you can do it or not. Because you'll probably learn something in the process. So that's what we'll be doing today. Take a look at these notes here. So hopefully we can add some more color spaces after we do that. Like lab, for instance, would be nice. Now I made a couple small changes just offline. I'll just quickly summarize those. So HSV to RGB, I just cleaned it up a little bit, reorganized everything, made it a little bit more readable. Made sure like K actually corresponded to K up here, as opposed to what I was doing before, which was just K was just some random name. There's like no generated code change from doing this. Actually, I'm noticing I probably should have removed another space here, but sure, let's do that. And then fill HSV to image. I removed like the last color, color from HSV all, which was for H. And the reason was before is that I'm just assuming here that HSV, in my HSV to RGB function, I'm assuming H is from 0 to 1. But the color from HSV needs it from 0 to 360. So this here was like 360, which is why it was just like, even if I build it now, we'll see. You can see there's like many small rainbows going on here, as opposed to just the one that's supposed to be happening. So that's better. I fixed that, and then I just combined the three separate sections here. Let me just make sure this is working. Okay, so I just combined these three sections into a single loop, because there wasn't really any reason for it to be three separate loops. I'm just doing the exact same thing. And the ball just like collapses down really nicely. Probably this could be like moved outside the loop, so hopefully the compiler just sees that that's not a changing value and doesn't decide to compute that every time. But sometimes it's better just to be explicit about what you want computed and what you do not want computed every time through the loop. So that's good. And then other thing I did was I just oh yeah, so this one I didn't move. Where was it here? The color stack. So I cleaned up like all the static variables for the color stack. These could have got pulled in. So now I have a color stack. I have a color stack state struct, which just contains all the state for these. So like all the floating whatever state and all that stuff. Like which like this like that time fading parameter and stuff like that. That's all just put in this like color stack state. So now, not that it matters at all, but like if you were to reload while you were in the middle of doing some sort of lerp, it would like maintain its state, but it doesn't really matter. It just won't get reset. So probably I should do the same thing for the where are we here? For the status bar. So like these slider scales probably could get stuck into a struct as well. That would make sense. It's like right now I think if you had like this and then you like reloaded, I like managed to do it. Not really. Well, anyways, it would probably be better if these were not stored here in static memory. Same thing with like this held IDEX, same thing. So anyways, that's that. Let's do this. Let's do this RGB to HSV conversion. So to do this, not sure. I should probably just leave like the comment again, explaining what's going on here. So H is defined as a piecewise function. I don't know if I want to read it. I really don't want to type this comment for how this is just done. Let's go to Wikipedia. Pull this out of here. So if we bring this over here, where's the conversion? So what we need to do first is find the maximum of the RG and B values and find the minimum of the RG and B values. And then find this like chroma or contrast parameter. They're saying it's called like chroma. I'm not like a color nerd, so I don't know what the difference between chroma and contrast would be. To me, this just looks like contrast, the difference between the minimum and the maximum value. Just seems to me like a type of contrast, but anyways. So we need to do this calculation, and then based on this result, specifically the maximum, we can calculate this H prime, which is just H from 0 to 6. And then we're not going to do this. We're just going to divide it by 6 to get it in the normalized 1 space. I don't really care about it being in 0 to 360 degrees. Doesn't really matter. Typically measured like that, I don't really particularly care about. Typical. Now there was a good question about the color space yesterday, which was is this being done in linear or sRGB space? And everything here is just done in linear space. And you can tell OpenGL to just apply like a gamma correction for you. But as far as I'm aware, I mean, I could look into the code a little bit more, but I don't think Raylib just does that. It doesn't really matter that much. If you care about colors, maybe. But I'm not going to worry about that right now. So let's start by doing this max calculation. So we're not including math.h, so I can just use the word max as a variable name. So we're going to have well, we could do this max min c to start with. It's still too hot. Not yet. And then so to do the max, I think what we need to do is make 3 temporary registers that are just like swizzled. So basically what I want to do is, let's leave a comment for this. I'll probably delete the comment, but so the max is just going to be equal to the max between RGB and GBR and BRG. So there's like a swizzle thing going on here. So at the end, after we just calculate this, we don't need the spaces. At the end, all 3 lanes of this integer is just going to have the maximum value in it. And we'll do the same thing for the minimum. Now, these are 4 component things. So ideally, we want A to just get passed through. I'll have to just look at the intrinsics and see what there is for like swizzling. Because that is what is important here. There's like blend. What does blend do? Blend packs using control mask. I don't think blend is what I want, right? So blend, let's bring this over. And explain what I'm talking about. Maybe bigger even. Yeah, so blend. So you pass it in this immediate 8-bit what? Immediate 8. Isn't that, I don't know if that's actually supposed to be 8-bit. I guess, sure. Yeah, okay, whatever. It's just an 8-bit value, but it's using 32-bit storage. That's fine. So if bit I, so if bit J, if bit J is set, there's 4 bits. We care about 4 bits. So if bit J, so if bit like 0 is set, then so for each bit that's set, basically what happens is we just copy. So if 1 to 31. Yeah, so okay, so this is like kind of hard to explain. Basically, if the lowest bit is set, then we take the lowest 32 bytes of B and store that in the result. If it is not set, we take the lowest bytes of A and store it in the result. So I don't think that's the operation I just want. Probably it's these shuffle. Yeah, it's definitely these shuffle single precision floating point elements in A using the control. So why is there 2 parameters though? Good question. select for. This is like a really hard thing to read. Select for is taking a control, which is 2 bits. So it's 0, 1, 2, or 3. And then it's choosing which of the source bits to take based on that. So why is this like taking 2 parameters? I don't really understand why it's taking 2 parameters. Like, so what about these insert? What does like insert do? Maybe it's insert that we want. This is definitely going to be like going into the debugger and just stepping through to make sure I'm doing the right thing. The definitions for all of these just gets like worse and worse. It might be better just to like do a quick search. Let's do a quick search here. Pack. Okay, we're gonna try this. Whether I just trust if it works or not. You know, ChatGPT. Sometimes ChatGPT can be useful for learning some things. Apparently, there's a macro. Is it defined in here? There's like a macro. Let's get rid of this, and let's just see if that macro exists. Um, okay, we can try. We can try this out. Um, so we do want like the old shuffle. Shuffle PS. Oops. So I'm gonna move that back over here for now, and zoom way the heck out so I can see what it is on my screen. So let me do this. Let's say that max is going to be equal to, first of all, we should actually load. We should do like a load here. So RGBA is equal to load u. So it may be not hard to say. But anyways, we'll do the load u. Just saying it's not, assuming it's not aligned. And we'll do the load u ps, and we'll just do the RGB.e. And that should be good for that one. So then we've got RGBA. And let's make the other ones. So we want GBRA. That's going to be a shuffle. And it's going to be shuffle PS, and then we're going to do RGBA and RGBA. And we're going to do, I'm going to try this macro and see if it just compiles or not, or if ChatGPT is imagining things. You never know, ChatGPT. It'd be something like this, and then the next one would be BRGA, and that one would be well, the same thing. You could just do the theoretically that should just work. Does that compile? Unused, unused, unused. Okay, that's fine. It does compile. Let's just turn the old debug down here. So we're gonna do that, and then we're gonna close this and go back to the debugger, and we're gonna open up that function. We're gonna crash. Good, cool program. Let's hope it doesn't crash this time. Okay, I have to run this first, and then I can put my breakpoint here. Yeah, there actually is where it would show up. So we're there. Let's look at our, let's continue until we hit that again. Don't know why that happened in such a slow way, but anyways, that's okay. So let's look at our locals. Let me just check and make sure this is visible. It's somewhat visible. That's okay. We just need these. Let me put it up here actually. So if I do this, yeah, that's visible. So then GBRA. Wait, why is that? Oh, we haven't run the instructions yet. That's why. It's just garbage. And then BGRA. What's it called? BRGA. BRGA. Those are just garbage. And then finally the RGB. So these are the values that we should just be seeing after these loads. So if we go next, so that's just correct, obviously, because we're just loading. Then Let's go next and next, and let's just see if this did what we wanted. It did not do what we wanted. So let me see here. So the green did go to the right position. This just did the whole. This is like the rotate. This was basically just the whole rotate, which is not what I wanted. So we'll have to go back and fix that. So this. Let's have a look at the old intrinsics here and see what it just says. Okay, so of the destination, bits 0 to 31 are bits. I almost feel like it's easier for me to just type the hexadecimal thing in. Like what does this evaluate to? I'm sure it's just some hexadecimal value. Can this calculate it? No. Yeah, so that's not gonna work. What I can do is just assign that to a value in here. So let's do I'm just gonna copy this and oops and store it here for now. What on earth, vi? Let's just try this again. Okay, so what is this mask? We need to step over it. So it's 57, which in x is 0x39, which is so that's gonna be bit 8 and bit 1 set. Can I do like binary? No. Yeah, that's a bit more easy to read. So it's basically 0 0 0 1 1 1 0 0 1. Oops. So yeah, it's this. Except I think let's type this in hex because I don't know what's going on there. It should be yeah, so 0 0 1 1 1 0 0 1. Probably in the other order is why that's happening. But I don't know why that's getting evaluated like that. Anyways. Yeah, I'm not sure what GF2 is just doing for that. But that's okay. So the lower two bits here are just 1, evaluate to 1, which means it's going to copy 63 to 32 into the destination. So that part's right, obviously. And then for the second part, we're looking at bits 2 and 3, which in this case are 1, 0, which is 2, which means it's going to take the next 2 and copy those in. So it's going to take, yeah, it's going to take, I don't know if I like this mask thing. It's kind of difficult to read. Let me just look at what this map. I'm just gonna look this up properly on the old Google here. Um, oops. So I feel like it's easier for me to just write this myself. I don't know. I see. So we can probably do. Let me see here. So, well, probably what I want is. I am looking at this wrong. So this 1, 2, 3, 0. Okay, I see. Yeah, yeah. Okay, I see what's going on here. So 1, 2, then the 3, and then the 0. Um, that makes more sense to me. So the lower two bits are the 1, which is gonna take so from the first argument, it will take bits 63 to 32, so like the G, and then it will shove the G into the first element of the output, and then it will take, so then for the 2 here, it's going to take, again from A, it will take, it's 95 to 64, which are the B. That's correct. And then for the next one, for this 3, it's going to take from B here, and it's going to take bits 127 to 96 and put that in the third element, which is not what we want. We want this to be a 3. So as usual, ChatGPT's like making stuff up. We want a 3 here, and then we want a 0 here. I believe, so that would correct the first one. I don't know about the second one. We can check. So also this is like really slow today, so I don't know how far I'm gonna get. That's okay. So let me see here. So did we actually stop somewhere reasonable here? Apparently we did. No, we're not. We're not even stopped. Okay, now we're stopped. Just gonna do that. And we'll leave that here. And we will do a step, step, step. And we'll look here. So the 1 is preserved, which is what we want. Here, we want this to be moved to the end, and we want this to shift up, and then shift up and move to the end. So this is actually now correct. So ChatGPT was just given some hallucinogen again. So now, right, is this BGR? So B, B, and then G. Oh, BRG, sorry. Yeah, BR and then the G. Because now we can, so that's what we want actually. So we'll get rid of this breakpoint. Get rid of that breakpoint and continue. Go back here. So now if we do the max, we'll get exactly what we want and the min. Let's actually probably just delete these variables up here altogether. We'll do the max. This is going to be equal to mm. We used this before, max. Yes, and we're going to do RGBA and max PS, GBRA and BRGA. Okay, so that's going to give me the max value, and then for the min, we'll do the same thing, except now it will just be min. Then we'll have the min and the max, and then for the contrast, it's very simple. Sub PS, and it will just be max minus min. We call that capital M. So that'll give us those values, and then we'll have to construct an output mask for the H. But first, what I'll do is I'll just calculate all H values in parallel think. So yeah, how can I just do that? I want, yeah, this is a bit annoying. plus t here. And this t, let's just do this. This t is going to be basically we're going to extract a single value from h when we're done. This is a little frustrating. So let me think. Probably so I don't want to be like completely wasteful with what I'm just doing here. I think it's gonna end up just being wasteful though, no matter what I decide to do. Basically I need to do like this, do another mod, which we did down here. We know how to do the mod with the vector instructions. The mod is here. It is this division and this floor, and then do this multiplication, subtract it from the original value. This is the mod. I don't want to link in the math library to do any of this stuff, so let me think here. Probably I'm just gonna have to do the masking anyways, so we'll just start by doing the this is gonna be equal to we want GBR. We have a GBR. I think we do have a GBR, right? GBRA. And then BRG. So BRGA. We have the BRG as well, so that's good. The only problem here is that this is gonna just go to 0. Probably we can extract the alpha later on, possibly. And we want to actually do a division here as well, which is dividing by C. And then close that, and then divide by C. That's going to give us the first part, and then the second part is to construct like a mask. Then we have to add. The add part we can just do oh, even better. I think that this add part will probably just work fine. So do this again. We'll do F32. Add value. A val. I don't have a good name for that. It doesn't matter. And this is going to be equal to Yeah, let's do 0 to 4, and I don't want to do that necessarily. I feel like doing this is kind of dumb. But we'll just leave it for now. Check if because maybe we could just do like a mask. Considering we're going to be masking off the correct value for the hue, maybe I don't even care about the A. Yeah, maybe the A part doesn't even matter here. That's quite possible. Put a 0 there. And we will do the T is now going to be equal to okay, so that's that first part, and then we need to do like a mask. So to do the mask, how do we do a mask? Maybe we don't need to do a mask because we can just use the blend. We can use the blend afterwards to just select the correct ones. So yeah, let's do it that way. P mod is going to be equal to let's do some modding here. So I guess I have to yeah. So okay, we want to calculate T mod. T mod is going to be equal to its remainder T mod. Do it this way. So it's going to be this remainder, and it's going to be sub of T minus that. I think I need T. I think I need a copy of T actually. So T is actually going to be the final. Oh yeah, sorry. Yeah, this is correct. I haven't actually modified T here. We still have T. So that's good. So here we've now got the mod, and then we need to do like a blend to get the H. This is not even H yet though. This is like an intermediate H. Like let's actually look at the blends. So maybe we can combine this. We can combine this step with the masking, probably. The blend just selects which floating point values to use. Okay, so bring this back over to the view here. So here, the final H value should just be calculated this, calculated these ones, calculated this one, just implicitly. So basically, if C is equal to 0, this should just be C, is how we're defining it. Let me see here. So what do I want to do here? So I want to calculate which of the M's is the mask. So we need to make a mask. So we need to figure out we need a mask. But actually the mask is a little weird. So the mask should be an 8-bit mask. And it should only have 4 bits set. Which makes sense. So there's only 4 options here. What's the best way to construct that mask? So there's so compare equal will return that. How do we get because the thing is I don't need the I just need the I just need the result. I just need a single bit result. So let me see actually, does compare equal just fill in the I can actually read what this is trying to tell me because the page is like broken. Okay. Yeah. So it will just give you like ones in so we can just do the so we need to figure out which of the max and the min. I see. So this is like a little bit of a problem. So the maximum of maximum. Let me get rid of this for now. So we need to take. So this is not what this variable is called. It's basically if we take this max and we compare it for equality with this, that's not what we want though. No, it is what we want. It is what we want. So The only problem is that the A part is going to be set as well. I need to find like the first bit that is set besides the A bits. And that will tell us if it's red, green, or blue. It was the max. So let's call it so max C is going to be equal to I feel like I've done this before. I mean, there is some ones that will return an integer, but none of those are what I just want. Um, how do I do this? So how do I figure out? There's actually what are these? There's like this move mask. What is this? We want this like move mask. Right, okay. So we need move mask. Move mask is gonna be our dealio here. Um and we're gonna have to mask it off. So we're gonna do this, move mask, and we're also gonna do what's like the comp equal thing? Comp equal PS at single, and then it's gonna be RGBA and max. And then we're gonna do an AND here with the basically 0x0 what's the 6, I guess. What I want. So I don't want to set so the like the lowest value I believe is the A. Or is that actually the highest value? Did we see here? So that's 3. 3 should be like the highest value. So I don't care about that. I actually care about like the lower 3 bits, the lower 2 bits. So just a 3 there. Um, Quick note there. That's going to tell us the max color, which is also going to tell us which of the H results to take, and then I don't think we need to know what the minimum is. Possibly for the other ones, like the saturation and the value. Saturation, no, but for the value, we need. There's different ways of just doing it. The value is just the largest value of, so it's just the maximum. So I don't actually need the minimum anymore. The minimum was just needed for the contrast. Okay, so that's good. So that's giving us part of the mask, and then, or the mask itself, I guess. And then I should step through again and just do the, get rid of this part, comment. Let's do a rebuild here. Oops. We do need the sixth part here. Let's copy that up here. There we go. Let's do that. Those are unused, that's fine. So let's go back to this. And we're gonna do a run fresh. Hello. What is happening? Again, good job, GF2. Okay, we'll try that again. And this time we'll go back up here and we will place another thing. We'll do that. Okay, we need to continue because it just wants to do some stupid. Continue, switch to RGB, switch back to HSV. That can get deleted. Same with that. So we are going to do some stepping here. Okay, obviously the maximum value is the green for this one, which is stored correctly. Then the minimum value was the red. We get our contrast. And we get this. I don't care about nan. It's just 0 divided by 0, so I don't really care about that part. That's still just nan, it doesn't matter. Can just ignore that for now. And then that should be correct. And then this move mask is going to give us a 2. So what's our mask? Sorry, max C and an X. So that's a 0x2. So which I think that makes sense. So the maximum value is the green, which is this would be 0, 0, so it's probably, you can't even see that one, that's probably behind the camera. Right, okay, let me just bring this down here. So 0, like bit 0, bit 1, bit 2, bit 3, so 0, 0, 1, 2, 3, it's just like the opposite of what's just displayed here.
So if it's 2, it should be this. So that makes sense. Probably I should try with like like make the red one a maximum. So we'll do that quickly here. Switch to red, switch back. That red's the maximum now. Should be anyways. If we just step through, so sorry, the max. I don't have max here. So max is this 5, which is the red value. So then if we keep stepping, this gives us a 1, which would be, I was expecting it to give me a 3. Well, this is useless, this mask. Sorry, this mask is just wrong. Yeah. If I'm trying to avoid bit 0, I need to just and with 2. That's not even right though. I just don't want like the 0. So I think I need to yeah, I don't want the bit 0 there. So based on the most significant bit being set. Just get rid of this mask and let's just do this. Copy that. Why did you jump like that? I don't know what GF2 is doing. Just wanted to copy that code and evaluate it. Fine. Just get rid of this mask because it's bogus. Okay, so we will do the run. Without the mask, we get a 9, so so that should be giving us both the lowest bit and the maximum bit. So the maximum, I see. It's using 3 bits. That's correct, I guess, based on what it says. Move mask. Oh, right, yeah. So move mask is returning 3 bits. Yeah, let me switch this color back to something green. So the green's the maximum. So 10. So 10 would be, again, that highest bit. And then it's second bit. So yeah, so 1, 2, 3. This is the highest bit. I just want to get rid of the highest bit. So this 0, 3 was correct.
I'm not dumb. It was the 0, 3. I will get rid of the highest bit. Which I don't care about. So we'll do that. That part's correct. And then, okay. So it's either, so if it's green, it's 1. Let's just leave some comments here. So this is going to get deleted. So green gives red max C equals 2. Oh no, sorry, 1. And then green is 2. So then blue would be 3. Okay, so based on this, we can do like a blend. So we're going to use this max thing as a blending parameter. So go to blend. Go to blend. What we want to do is let me see here. Is going to be equal to 6. So we have to do the division by 6 at the end. And then blend yes. And how do we do this? This one. So basically we want to pack, we're going to want to use this shuffle again to pack T mod and T together. Then we can do or never mind, we don't need to. We can do this blend with the T and the T mod and the max C. Let me see here. So when blue is just the maximum, what are we supposed to get in the H? We're supposed to get the R minus the G. So where does that show up? Which section of the, in this T, R minus G would be it should be in like the blue position, right? The normal blue position. So I believe this is just correct actually. Yeah, let's step through this. I think this is correct. What is the problem here? Yes. That must be a constant integer. Did I make a mistake here? Oh. Yeah, we can't use blend PS. That needs to be an actual compile time constant integer. We can use blend V. Now blend V does something a little different. Yeah, so blend V, we have to do something. This max needs to be something different here. So let me see here. So this blend, um, right. And then the alpha is just gonna still be correct. Let me see. So if the mask from I31, so if it's just set to ones, I guess, it doesn't really matter, probably. Yeah, if it's any value, I think. Then we copy from argument B to dest. Otherwise, we copy from A to dest. So in our case here, we've got M is equal to if M is equal to R, so in that case, this R will be set, and then it should be the first thing, which is the G minus B over C plus the mod. So I believe T mod is not going to work. This isn't going to work properly though. So T mod needs to be this isn't going to quite work how I want it to work. I think this is going to, let me just try. Is part of the way. Mask. Okay, don't care about that. Go back here, do another run. So, okay, so I'm predicting that when R is the max, it should just work. Wait, why is that why did that happen? Oh, sorry, it sets all the bits. Yeah, never mind. That's correct. Yeah. Just ignore the value of that one. Oops. Got the order wrong there. Let's fix the order. You divide this result by 6, not the other way around. Okay. Let's do this again. Oops. So what H should just be is I did this in a dumb way, but H shouldn't be 0. What? Oh yeah, H should be 0. Never mind. That's correct. That was dumb. So H should be 0. Which is what we got in the H register here. Like this first one. It's just like the selection part where we select which of these we need to take. So possibly I still need to do that like integer to move mask and mask off the bit. And that's going to tell us which element to just take. So I did set that to, so let's just try this with another value. Let's continue. And we're going to set this to green being the maximum. So if we go through here again, so it should be, I think this is the wrong one. So just do this one as well. The 117 divided by 360 because I can't do that. Do it this way. 117 divided by 360 is like 0.3. That's actually correct. That's the second value here. That part's correct. So what about for the blue? I'm just thinking one of these is going to be completely wrong, so that's why I need to check these. We want the third value to be correct. So it's like this 0.66, which we have to do this division by. I think that looks relatively reasonable, actually, so maybe it is just correct. 239 divided by 360 is the 0.66. Yeah, so that's actually correct. It's like kind of, so we just need to figure out how to extract the correct at the end here when we go to just select. We want to basically we need to pack all of this stuff into an HS, just into a single register. So ideally we want to make sure that we can get. So we can't use this shuffling. That's not going to work. We need to get basically I always want the H value to be stored in like the first one. So how can I do that? Let me just get up for a second here. So the funny thing is that I guess not the funny thing. The nice thing is that h is actually the only complicated thing to calculate here. So once I just figure out how to get the h to the correct position, then it's like pretty much done. Yeah. Let me see. So we need to programmatically shuffle the. I think it's still just like blend, right? Or like, is there like a different shuffle? No, there's not a different shuffle. It's still just like the blend V. I just need to like use the blend V correctly. I guess maybe I'm not even using it correctly here at all. So I want basically I want this mask to be such that um when we go to what's it called? So when we go to select, so like what we're trying to do here is select a value from T mod or T. Now T mod and T, I think they need to just be combined first. That might be like the main problem. So we should like combine T mod and T in exactly the correct just order that we want them to be in using the shuffle. So I think that's correct. I think we want to do that first because that's going to help everything out here. So what we're going to do is take T again and we're going to do shuffle T and T mod, and then it goes this shuffle view. You just look again. So we want that 3 and the 0. The 3 is just correct. So the 3 is the highest bits. So we want the highest bits to be it's like the T. I want to actually check this here. Is this T mod? T mod does not have the correct value for the T also does not have the correct value for the alpha. Okay, that's fine. I don't need to take the alpha from H. Um, that's actually fine. I don't really care then which one we take that one from. And then for the second one, uh, it's again coming from B. So if we want the max, we need that to be in A. So this order is just wrong. I should do P mod and E instead. And then, oh, but see, this still doesn't work. So you can only salute. This is like the weird thing about this instruction, is it just takes from. I guess it is just blend again, and you just have to. It's blend, but the mask thing is different, so that's why. So yeah, it's blend. Um. So okay, and it's an immediate thing here. I don't know if there's like a macro for this. Basically, it should be 0x So for the high bits, okay, so right. The highest bits are when J is 3. So J3 would be, we don't care what J3 is. So I'm just going to type it in binary here. So J bit 3, we don't care. It can be 1 or 0. It doesn't matter. They're both NaN. And then bit 2, we want no, again, this blend is incorrect. Blend is not what we want. It's like you need like both a blend and a shuffle. Yeah, you have to use both the blend and the shuffle. Okay, that makes sense. Okay, so we have to do the shuffle on the T-mod first, I think. So where does T-mod have the value I care about? Only in like the 0 position, right? Let me look here. Where's T-mod? So, okay, so actually it's already in the position I want. Um, oh, if that's the case, then the other things are in the positions I want as well. Never mind, I don't have to shuffle it first. So 0, and then we just care about the A parameters here, so, or the B parameters. So we want 1, 1, and then 0. So that is just 8, and then 12, and then 13. Oh, yeah, duh, just E. Good. Yay, magic numbers. Take, what's it called? Okay, so that's going to give us that one. And then here, we don't want to do this blend anymore. So we've got the correct... So here, this T parameter now has the correct things, and we just want to mask off parts of it based on this mask. And possibly shuffle it around. Huh. I have to stop here for tonight. My brain is a little tired. Let's just have a look at where we're at. So doesn't matter. I just want to see if that blend is correct. So we got like these should be the same, and then Tmod. Oh, sorry, not that part yet. Keep going. Okay, so this line. Okay, so yeah, these should be all the same, 2.023 nan, and then why are these like the same still? This test isn't useful with this color. I need to change the color to be so that the red is the maximum, because then it will make more sense. Because that blend isn't going to tell us anything. So we'll continue, and we'll make the red the maximum. Okay, let's try that again. So, is this like always just going to be the case? We need the maximum to be red, and we need G minus B over C to be greater than 6. Is that even possible? No. Not if these are normalized. Like, what is C? C is not... Yeah, C can't... C is always... Okay, so C does make the thing expand. C is always going to be less than 1. But that subtraction is also always going to be less than 1. I don't know if it's like possible to make it blow up to over 6. Like, is this whole thing just assuming that these were in RGB to begin with? In 8-bit integers? It doesn't say anywhere. So I feel like the mod 6 part is never going to be correct. I feel like it's always just never going to give any real value. I'm going to put a note there. Actually, I can just do this right now. So if C over... So first of all, C should always be greater than 0. It can be 0 or it can just be greater. It can never be less than 0. So basically what we're saying is that G minus B has to be greater than 6 times C. Now, this is G minus B has to be greater than, like, what would be the maximum? How do you get like the maximum contrast? It'd be like 1 and a 0. So it'd be a minimum of 0 and a maximum of 1. That would give you the maximum contrast, which would be a 1. Oh, so actually we want the minimum contrast. So like a 0. Okay, so yeah, if that was close to 0, then G minus B could be like... The problem is like G minus B then, if the contrast is just 0, then the G minus B is also going to be close to 0. I'm not sure. Yeah, I'm not sure. I have to do this properly, do the math properly, because possibly G minus B is never less, like possibly this thing never exceeds 6, and this whole mod thing is just a waste of time. Okay, let me see. That comment is wrong. That comment is wrong. Okay, so let me think here. I basically just need to shuffle this around so that the maximum value ends up in the one position. So how do we do that? Like in the zero, the lowest position of the thinger. Um, that'll be good. Let me see here. So okay, so we find the maximum, then we shuffle to the position. So find the maximum. I already know how to do the maximum. Um, I'm not sure. I have to look it up. I'm not actually sure if it's like easily possible to create this operation in SIMD. I think it is. I think I just don't know how to do it. So basically just need to So we want to make sure the position yeah, I need to because the problem is like this a lot of these a lot of these commands take immediate values, which means they can't be specified at runtime. They have to be specified at compile time. Um, which therefore means that you cannot use these with like some mask you just constructed at runtime like easily. You can like add like a switch or like some branching. I'm trying to avoid adding the branching to do this. So maybe like the more appropriate way would be to construct all of these. So right now I'm constructing these all in a single go. Like this one here, this T. Let me just bring up the Wikipedia here. So I'm constructing all of these in a single pass. Besides this mod part, mod part's like separate. It's actually possible to do the thing without the mod. Let me look at the mod actually, the mod operation here. So right now we have 6 in all the positions. Let's say we didn't have 6 in all the positions. So we had 1. If we had 1s in these other positions, so then this division would just give the same result, and the floor would round down to, well, the floor part would screw everything up. So the floor would make it go to, yeah, the floor would do like a rounding dumb. Um, so if you did the division with like a really big value in those other positions, then the floor would go to 0. And then this here would leave you only with the, yeah, okay. So I will look into this. So to do, construct the divisor such that the floor of the result is 0. Let's get rid of this. The floor of the result is 0 for all positions besides position 0. Is it position 0? So that would be this one. Yeah, so it should be position 0. Yeah, besides position 0. Divisor. It should be like divisor. Yeah, there we go. That was divisor. That's better. Okay, so right, that is gonna be all for me tonight. Fortunately, we didn't quite get there. As I thought, this is a little complicated to do. But that being said, we are pretty close. So once we get h, the other values are very easy to very easy to calculate. So like I could have just calculated them on the side. So v is just the maximum of the RGB. We already have that calculated. So we already have v. And then s is just the contrast over v, as long as v is not 0. So again, we already have all this stuff just available. So yeah, those two values are like it's just going to be, shuffling everything around, getting the correct values inserted into the output. I mean, possibly you could even leave the compiler to just optimize those ones. So like I could just uh, load out the results for each of these and just take the values and just manually construct it like I'm doing down here, and that would give you the right value. And then hopefully the compiler would show us. I could look at the compiler output and see what it was just saying about how to do that with the old vector instructions. So that might actually be that's like the dumb way, but it's also like a practical way of just figuring it out. So see about that next time. Maybe I'll just do it offline. Because on the next stream I think I want to do a different project. So uh possibly I'm not gonna be working on this one. Possibly I'll just finish this calculation offline. But we will see. So thanks everyone for watching, and I will see you all next time.